your high-tech EV packed with thousands of dollars of advanced battery technology, rendered useless by a component you could buy for 50 bucks. This video explains the weird but dangerous truth. Modern electric cars still depend on a tiny 12-volt battery to run doors, computers, safety relays, and most of the car's brain. When that little brain fails, the whole high voltage system can be locked down or go limp, and drivers are left stranded. I'll show you how this happens, why it keeps happening across brands, real world recalls, and legal headlines, and what engineers are doing to stop a $50 part from breaking a $60,000 vehicle. Think of the EV as two electrical worlds glued together. The big one is the traction battery, the giant pack that actually moves the car. The small one is the 12-volt system, which runs the lights, locks, infotainments, safety systems, and the control electronics that decide whether to connect the big pack to the motor. The 12-volt battery doesn't drive the car, but it's the gatekeeper. If the gatekeeper has no juice, the car's brain can't wake up, contactors don't close, and the high voltage system stays offline to avoid unsafe behavior. The 12-volt system is charged from the main pack through a DC-DC converter. That converter keeps the 12-volt battery topped up while you drive, but it's not an invincible link. Software rules and hardware protections mean the DC-DC will stop recharging the 12-volt if the main pack is too low or if the converter detects a fault. That's a sensible safety design, but it creates a brittle chain. If something causes a 12-volt to sag repeatedly, the car can fall into a state of where it won't restart, or it refuses to engage the main battery until technicians intervene. Modern cars can also allow parasitic draws, always-on modules, telematic boxes, aftermarket devices, or even software bugs that slowly drain the 12-volt while the car sleeps. The result is an unexpected 12-volt battery death, and a car that won't come to life. This isn't hypothetical. We have seen mass recalls and thousands of owners' reports about 12-volt faults that disable EVs. Hyundai, Kia, and Genesis recalled nearly 150,000 EVs in the United States over an electronic issue that could let the 12-volt battery lose charge while driving. That recall shows this is not one-off problem, but a systematic safety and reliability risk on high-volume models. Car brands have also faced waves of owner complaints and legal actions. Public reporting on Toyota and Subaru's BZ4X and Solterra models describes repeated 12-volt failures that left owners stranded and sparked a class action lawsuit in the US. That case centers on repeated rapid discharge and failures even after replacement under warranty, highlighting that swapping the battery doesn't always fix root causes when the vehicle architecture or charging logic is deeper problem. Rivian redesigned how its 12-volt system is maintained after owners and technicians found failures and related hazards. And the other makers have had to patch software or change control logic to prevent the DC-DC converter from misbehaving. These moves underline the point. The 12-volt issue touches software, hardware, and supplier parts, and it can force expensive fixes or recalls. Here's the paradox. EVs promise fewer moving parts and lower maintenance, but 12-volt failure is a cheap single point of failure that can render advanced safety systems, and even the high-voltage battery inaccessible. Customers expect a modern EV to be more reliable than an old ICE car, not to be stopped by something you can pick up at an auto parts store. The challenge for engineers is to make the 12-volt system resilient, observable, and repairable, without exploding the cost or complexity of the vehicle. Two immediate technical challenges stand out. First, how to prevent the 12-volt from being drained by parasitic loads or bad components, without annoying an owners with frequent maintenance alerts. Second, how to design the DC-DC charging and vehicle control logic so the car won't lock out useful functions when it detects marginal 12-volt states. Both problems require software, hardware, and systems thinking. Engineers and manufacturers are attacking the issue in several ways. One approach is better monitoring and smarter control logic. The vehicle can watch the 12-volt voltage, measure parasitic drain when parked, and learn normal patterns. If abnormal drain appears, the car can put offending module to sleep or warn the owner early before the battery drops too low. Predictive diagnostics like this help catch problems before they strand drivers. Another move is changing the 12-volt chemistry. Many early EVs used conventional lead acid 12-volt batteries because they were cheap and well understood. But lead acid struggles with deep cycling and long periods of partial charge while vehicles sit. Makers are increasingly switching to lithium based 12-volt batteries that tolerate deeper discharge, have longer life, and weigh less. The transition has trade offs. Lithium 12-volt parts cost more and need different charge management strategies, but they reduce the failure rate and improve longevity. Industry analysis and supplier trends show an ongoing shift toward lithium auxiliary batteries in many newer designs. A third approach is redesigning the vehicle's power architecture. Some manufacturers add redundancy or higher voltage auxiliary systems. Rivian's second generation R1 platform changed how the 12 volt is maintained to be more robust after early issues. Software patches have been used to throttle non essential loads and to change how the DC-DC converter behaves under borderline conditions. Where possible, OEMs are implementing hardened clamps and bracket designs to prevent physical damage to the 12-volt battery in crashes or during service. A fourth tactic is better customer guidance and serviceability. If some EVs lose 12-volt charge because owners leave too many accessories on or install third-party trackers, then better education and easier roadside service can reduce the problem. But education alone isn't enough when design or manufacturing flaws cause repeated failures, as recalls make painfully clear. Now, the crucial moment when you connect all the dots: parasitic drains, fragile lead acid chemistry, control logic that shuts off DC-DC converter for safety, and the physical design choices that make a battery hard to access. You see why a cheap 12-volt cell can become a silent killer of usability and trust. Imagine a driver on a cold morning. The 12 volt is weak because a telematic module drained it overnight. The DC-DC converter detects an anomaly and refuses to charge to avoid a suspected short to protect the traction battery. Because the gatekeeper isn't willing to close the contactors, the car won't start. Towing and dealers' visits followed. That single point failure cascades into a major customer experience problem. Warranty costs for the manufacturer and the bad headlines that slow consumer acceptance of EVs. Real recalls and reports show this exact chain has happened more than once. This is the core tension. Manufacturers must balance safety logic with user convenience, err on the side of the permissive behavior and you risk unsafe states, or battery drain. Err on the side of the protection and you risk the perfectly safe cars being immobilized. That trade-off is why software patches, battery and chemistry changes, and hardware redesigns are appearing across the industry. To summarize, the 12-volt anomaly isn't a small quirk. It's a systematic weakness that turns cheap auxiliary hardware into a potential showstopper for modern EVs. The core reasons are simple. The 12 volt is still the gatekeeper that powers safety and control electronics. It is often vulnerable to parasitic drains and chemistry limits. The DC-DC converter and vehicle software add safety logic that can be too conservative or brittle in the real world. And when a bad design choice, a faulty bracket, or a software bug shows up at scale, the result is a recall or a wave of stranded owners. Industry fixes are underway. We are seeing larger recalls and software updates from major brands to correct charging control issues and component failures. Some manufacturers are switching to lithium 12-volt batteries. Others are redesigning the control logic, adding diagnostics, or changing how the 12 volt is serviced. These steps will help, but the market will judge by reliability in the long run. High profile failures erode trust fade, and trust is the currency EV makers need to keep growth on the track.